Hello, welcome to my channel. In this video, I'll be talking about kinetic law of matter. It is an important topic in the JAMB UTME syllabus. Kinetic theory of matter explains the physical properties of matter in terms of the motion. Anywhere you hear kinetic, it has to do with motion. So what this theory does is that it explains the behavior, the attitude of the particles that make up matter. And that particle can be atom or molecule. To be atom if the matter is elements, and it will be molecule if the matter is a compound. Okay, so what it does is provides a molecular level understanding of the different states of matter, which include the gases, liquids, and the solids in terms of their energy and the motion. There are key assumptions of the kinetic theory of matters. And the assumption number one is that all matters are made up of particles. And is particle? Like I said in the previous slide, the particle that a matter is made up of is depends on the matter we are talking about. Okay? And the second assumption is that they are in constant motion. But the kind of motion that every particle of a matter will have depends on the state of the matter itself. If it's a solid, let's say this is a matter, the particles are usually tightly packed together because of the force of attractions between them. So they have a very limited motion and all they can do is to vibrate because they do not have enough space to move about and the force of attraction between the particles are very strong. That is in solid state. In liquid states, they have a relatively freer range of motion and they have more space to move about, unlike in the solid where they are tightly packed. While in gaseous state, they have enough space to move about. That is because the force of attraction, as it is assumed in the kinetic theory of matter between molecules of gas, is very weak. I want you to take this. Let's use water as an example. Water in its liquid form. Let's take it to be this. And let's assume this is in its solid form. Okay. When it is in ice form, which is the solid states of water, these molecules do not have enough space to move about, and the force of attraction between the water molecules is usually so high that they do not have that liberty to move about. But when they turn into liquid, which is water itself, they can move about. And when they are heated and they turn into vapor, in fact, they have more range of motion than even in the liquid state. Okay, that's the assumption number two. The assumption number three is that In the gaseous form, like in the vapor form of water, the molecules usually have negligible size compared to the container that contain them. I'm using water as an example, but this is applicable to any form of gas, be it oxygen, nitrogen, carbon dioxide. This will apply to them, okay? Assuming they are an ideal gas. I'll explain further what I mean by this in the later slides. And the third assumption, or the fourth assumption, is that there is usually no or weak force of attraction between molecules, especially when they are in gaseous form. As I use the water vapor as an example, okay? This is the fourth assumption. The next assumption is that in gaseous form still, when molecules move about, they move in random motion. And when they move in random motion, they collide with each other at some points. Okay? And when they collide, there is usually in the form of elastic collision, in which each molecule move apart. Okay? They move apart. This is how they continue to move. Okay? And as they move about and collide with each other, they also move and collide with the wall of the container. And when they collide with the wall of the container, they rebound, okay, and make another movement and continue like that, colliding with each other in elastic collision version and also with the wall of the container. Okay. The next assumption is that the temperature of a gas is related to the average kinetic energy of its particle, meaning that the kinetic energy of the particle is directly proportional to the average temperature. The kinetic energy of the particle is directly proportional to the temperature of the gas, meaning that as the kinetic energy increases, as the average kinetic energy of the molecule increases, also the temperature increases. When the average kinetic energy of the molecule decreases, the temperature also decreases. That is the assumption for an ideal gas. Now, having explained all the assumptions of the kinetic theory of matter, why are we talking about this? Why? So, the why, the reason, is what we'll be talking about next. One of the reasons why it is important for us to understand the kinetic theory of matter is that it explains the state of matters for us. It makes us to understand that solid exists as a solid because the movement of the molecules of a matter in solid state is usually restricted due to the strong force of attraction between the molecules. Okay? And the liquid exists as liquid because The force of attraction between the molecules of the liquid is not as strong as that of the solid. Therefore, they have a larger range of motion. While the molecules of the solid can only vibrate, the molecule of a liquid have a larger range of motion, okay, which is more than that of the solid. And it also makes us to know that when the temperature increases, the average kinetic energy also increases. And when the average kinetic energy increases, the matter usually change from one state to another. Meaning that when the kinetic energy of the molecules of the solid increases, it can change into liquid. Okay? And when it increases further, as we heat it, like I said, when the temperature increases, the average kinetic energy increases. When we heat an ice and the average kinetic energy of the molecule increase, it's turned into liquid. If we continue to heat it, the average kinetic energy of the liquid too will increase, and that will make it to convert into gaseous state because of the increasing kinetic energy of the molecules from solid to liquid to gas. The reverse can also be the case. That is, when we cool gas, the average kinetic energy of the molecule reduces and it's turned into liquid. And when we cool further, the average kinetic energy reduces and it turns into solid. Water is a good example of this. Okay, so it is the kinetic theory of matter that makes us to understand this. Now, another thing that kinetic theory of matter makes us to understand is the pressure. How does pressure that gases exert comes about? It makes us to understand that the pressure that the gases exerts is actually resulting from the collision of the gas molecules with the wall of its container. The sum of all this collision is what make up the pressure of the gas. Okay? And don't forget that as temperature increases, so also the kinetic energy of this increases. And when the kinetic energy increases, they move faster and they collide at a higher rate with the wall of the container. And the more they collide with it, the more likely the pressure will increase. So, the kinetic theory makes us to understand that as the temperature increases, so also the pressure of the gas will increase due to increased rate of collision of the molecules of the gas with the wall of the container. Boyle's law can be understood with the kinetic theory of matter. Boyle's law states that at constant temperature, the volume of a gas is inversely proportional to its pressure. provided that the temperature remain constant. The volume of a gas is inversely proportional to the pressure of the gas, provided this is constant. Okay? So what this simply means is that as the volume of a gas increases, the pressure of the gas reduces. Let me give you the example for you to understand. Let's say this is a gas in this container. If the volume of this container is increased, you can see the pressure in this container will reduce. Okay? If it is increased further, the pressure will reduce further. And this is understandable because, as we said earlier, that the pressure that is exerted by a gas is due to the collision of the molecules with the container. You can see that the molecules here, because they are more crowded, will be colliding with the wall of the container at a faster rate than the one that is bigger. So it is understandable, right? That is for the Boyle's law. For the Charles law, it states that the volume of a gas is directly proportional to the temperature at constant pressure. Okay? Meaning that if the pressure is constant, when the temperature increases, the volume increases. Okay? Let's say this is a container containing a gas with a pressure on it. If this pressure is constant, okay, when we heat this container, what happens? This, the molecule of the gas will be colliding with the container at a faster rate. So the pressure will want to increase. Okay? For it to remain constant, the volume of this container need to increase. Okay? So it is a kinetic theory of matter that makes us to understand this. Alright? Now, another thing that kinetic theory of matter makes us to understand is the diffusion principle. When you spray a perfume, let's say this is a room. If you spray a perfume at one corner of the room, in a matter of time, someone here will feel the perfume. How does it happen? The way it happens is that, like we said earlier, the kinetic theory of matter states that every matter is composed of molecules and they are in constant motion. So, the motion of the molecules of the gases from one corner of the room to the other will make it to become spread to the other corner of the room, making it to move from region of higher concentration to region of lower concentration. Now, do we know how that happened? Because when you first spray the perfume, the molecules here will be colliding, and when they are colliding, they will rebound and they will tend to go to more bigger space, and with time they will diffuse to the other corner of the room. It is the kinetic theory of matter that makes us to understand this. Now, kinetic theory of matter only apply to ideal gas. What do we mean? Ideal gas is expected to have molecules that is smaller compared to the volume of of its container, there is usually no force of attraction between them. All these assumptions, they are for ideal gas that obey the kinetic theory of matter. Okay. Real gas that exists, like the oxygen, the nitrogen that me and you know, they only obey this law under some condition. And that condition is usually when the pressure is not too high and the temperature is not too low. When the temperature is high and when the pressure is high and when the temperature is low, the gas that we know doesn't obey the theory, doesn't follow the theory of the kinetic theory of matter. Okay. And that is because at high pressure, they tend to come closer and the intermolecular forces become significant. So, and don't forget that in kinetic theory of matter, it is assumed that gases, the molecules of gases have negligible force of attraction between them. But at high pressure, this is not true. So if you want to apply the law, the kinetic theory of matter, it shouldn't be at high pressure, especially for a gas. Also at low temperature, there is reduced kinetic energy. Okay. And when there is reduced kinetic energy, this allows intermolecular forces to dominate. So this will violate the theory, the kinetic theory of matter. Okay. So in summary, what I mean is the kinetic theory of matter only apply to imaginable gases. Okay. And to the real gas, it only apply to them when they are not at high pressure and low temperature. Okay. Now, we'll go through a set of questions for us to test our understanding of the topic that was discussed. Okay, let's go to question number one. Which of the following correctly explains the relationship between temperature and the kinetic energy of gas particles? A. Temperature is proportional to the velocity of the gas particle. No, this is not correct. Temperature is related to the kinetic energy, not the velocity of the particle. B. Temperature is inversely proportional to the square of the kinetic energy. This is not correct. Okay. Rather, temperature is proportional to the average kinetic energy, right? 3. The average kinetic energy is directly proportional to the absolute temperature. This is correct. Okay. Temperature is inversely proportional to the velocity of gas particle. This is not correct. So the correct answer is B. Okay. Next, according to kinetic theory of gases, which factor primarily determines the pressure exerted by a gas on the walls of its container? A. The intermolecular forces between particles. No, because in the kinetic theory there is even no intermolecular forces between particles. The frequency and force of particle collisions with the container wall. Yes, this is correct. The size of the gas particles. No, this is not correct. The potential energy of the gas particles. No, this is not correct. So the answer is B. Which of the following statements about ideal gas behavior is correct? The volume of gas particle is significant compared to the container volume. That is not correct. It's usually negligible. It's insignificant. Collision between gas particles results in energy loss. No, this is not correct. There's usually conservation of energy when two molecules collide, meaning that energy is neither lost nor created when molecules collide. Okay? Gas particles exert attractive and repulsive forces on each other. That is not correct. There is usually no force of attraction or repulsion between them, according to the kinetic theory of matter when it applied to gas. Gas particles have negligible volume and experience elastic collision. So this is correct. The correct answer is D. Number 4. Which law states that at constant temperature, the pressure of a gas is inversely proportional to its volume? A. So what this question is saying is that at constant temperature, the pressure of gas is inversely proportional to its volume, okay, which is the same thing as volume is inversely proportional to the pressure, okay. So which law states this? But Charles' law, this is not true, because Charles' law states that the volume is directly proportional to the temperature, or temperature is directly proportional to the volume, okay. Boyle's law, yes, this is correct. Avogadro's law actually is different, and it states that equal volume of gases contain equal number of particles. Okay, and Graham's law too. This is not it. The correct answer is B. Okay, this is the next question. I will leave the remaining question for you to answer. Okay, so you can go through it, comment your answer in the section below, and let's open up discussion for us to understand more. Okay, you can like this video and share and subscribe to my channel so as to encourage me to make more videos. Okay, so as you are going through this question, you can pause it and read the question and then answer it and comment in the section below. Once again, like, share, and subscribe. I wish you the best. Thank you. Bye bye.